talk about the most evil word of all time, failure. I implore you all to please make mistakes, please fail, and please record everything you do along the way. Specifically, I'm asking you all to make mistakes in how you think about the natural world around you. It's not about what you think, or even how you think. It's about the fact that you're willing to think. The rate of change of the derivative, or the derivative of the exponential function, is equal to the exponential function itself. Also, the area under the curve, or the integral of the exponential function, is equal to the exponential function itself. Why do you care about this bit of calculus? Well, because till date, the human population has grown exponentially. This means that the number of people being born today is approximately equal to the number of people alive today. What does that say about tomorrow? It also means the number of people alive today is equal to the number of people that has ever lived and died. Think about that for a second. Now let's put these two facts together. This means that roughly speaking, the number of people alive today is equal to the number of people being born today and also the number of people that ever lived. One number. Being 1 in a million in the term of Christ meant that you were 1 among 300 around the world. Today, you'd be 1 in 7,000. Not very special. In recent times, technology has also advanced exponentially. To reach an audience of 50 million people, it took radio 38 years, TV 13 years, the internet 4 years, and Facebook, our beloved, only 2 years. What about scientific literature? The number of papers published in physics went from around 2,000 in 1900 to over 100,000 in 1960, and almost out of count now. Remember, each manuscript is a new piece of knowledge that adds on to this age-old field, and that knowledge has grown exponentially. Now let's move from calculus to history, specifically the ancient Greek thinkers. The Greeks integrated thinking into their daily routine seamlessly. Their gymnasiums were a place of exercise, of not just the body, but more importantly, also of the mind. Physical activity was combined with intellectual conversations. Art and philosophy were mixed with science and math. Here's one of the most fascinating set of individuals in ancient Greece. Not just because they're all historical giants, but because they represent a very interesting historical timeline. Plato was a student of Socrates, and Plato also taught Aristotle. Aristotle taught Alexander the Great. While each of them are notable in their own right, their combined multi-generational effect on advancing knowledge in humankind is almost unparalleled throughout the sands of time. Socrates. Many consider him the founder of epistemology, or the theory of knowledge, and how it's gained and how it spreads. He lived his life with a strict sense of ethics and philosophy until the very end. A strong believer in the social contract between the citizen and the state, he refused to escape prior to being executed by poison, even though his followers were able to bribe the guards. Due to his paradoxical thinking, he was found guilty by a jury of corrupting the minds of the youth in Athens. Plato. He was a scientist, an author, and a philosopher, and had huge effect in creating the basic fundamental thinking in a variety of fields. He found the common themes in mental models in science and mathematics and applied them to religion and philosophy. Next, Aristotle, a household name even today, one of the most well-known scientists throughout history who created some of the earliest theories in over a dozen varied fields. To this day, many of the rules of deductive reasoning he developed is still in use in our court cases. Alexander the Great. One-line description suffices for this ancient giant. In 13 years, he conquered and built the largest empire in the entire ancient world, an empire that covered 5 million square miles. And they were all students and teachers of one another. Now, you may be wondering why I went into a history lesson. It was because of the dates. Notice how quickly knowledge advanced and spread over a period of only 200 years. Both theoretical and practical knowledge in fields as diverse as philosophy, language, warfare, business, and politics grew exponentially. Now we further delve into Aristotle's work in the years following his death. Aristotle believed in a world consisting of 5 elements: earth, water, air, fire, and ether, which moved circularly around and described the natural world as he saw it, such as rain fell and air bubbles rose. Thousands of years later, John Dalton depicted the atom as a single sphere. He also posited the rule of greatest simplicity, which states, when atoms combine into one ratio, it must be presumed to be a binary one, unless some cause to appear to the contrary. What that means is he thought that water was OH instead of H2O as we now know, because hydrogen and oxygen were coming together. Then came the planetary model, which was presented by Niels Bohr. It was now clear that the subatomic particles actually existed. It wasn't just one mass. Electrons and protons and neutrons were separate things. This was developed to explain a Balmer series of visible spectral lines of hydrogen atoms. However, spectra of atoms larger than hydrogen did not seem to meet this model. This was quite a conundrum until Louis de Broglie proposed that all moving particles, especially electrons, exhibit a degree of wave-like behavior. This realization led to the modern quantum mechanical model of the atom. So from chemistry, we now move to photosynthesis. Aristotle, again, believed that the substance that causes plants to grow came from the soil. Aristotle regarded the soil as equivalent to a vast stomach that prepares and supplies the food of plants. He was a strict theorist and he never did any experiments. The first documented experimental scientist in this area was the Belgian chemist Johann Baptista van Helmont. His experiments showed that most of the weight of a plant did not come from the soil, but came from water. Later, Joseph Priestley found that a mint sprig would not die when placed in spent air, or air burned by a candle. Moreover, once the plant grew, the air would once again support the candle flames. The candle would go out, the plant would be there, and the candle would light back up again. This made Priestley think that plants would purify the harmful materials in the air. Later, the French scientist Antoine Lavoisier arrived at the understanding of combustion and respiration as processes that consume air and the oxygen in the air. However, the role of light was not understood until 1845 by the German biologist Robert Mayer. He wrote, "Plants absorb one form of energy, light, and put forth another chemical. Now, why do I mention these lineages again? 2 reasons. The timing is the first one. The timing. Notice the years. Notice how thousands of years pass for any scientific progress to occur on 2 very different fields since the time of Aristotle. Yet, once some progress is made, further change is almost inevitable, and within the next 100 years, it rapidly advances. The why behind scientific achievement is the existence of mental models and human beings' willingness and interest to think about new theories. While curiosity is endemic among us humans throughout all of history, we somehow choose to only parse them during certain periods of time. And during those times, science and philosophy is considered, for a lack of a better word, cool. It is when knowledge and philosophy is celebrated does progress occur. Now, what do I hope you take back from these theories and stories? It is that you stop believing in our model that society poses. Society tends to put everything into 2 boxes, success or failure. And it seems to think that stigmatizing failure will cause people to succeed. But I believe that there's a 3rd box, and it's called not trying. Fundamentally, everyone harbors great ideas, yet most of us ignore them out of fear of failure. We gravitate toward what is low risk or easy. In fact, alienating failure ignores a big secret around the world. As we just saw with these 2 examples, many of the people who have changed their understanding of the natural world were wrong. Not only were they wrong, but the person who corrected them was also wrong. And that, as a human race, we may never be right. But that has never prevented us from trying to discover more. Do not let the fear of failure get in the way of your curiosity. Use your curiosity to spark the next generation of exponential thinking and mobilize your 7 billion fellow citizens in the process.